energy.
Okay,
I think
good.
maybe I am little bit wrong about. I think it's vice versa.
Okay, good. So next is the energy challenge. Our global energy consumption is constant increasing due to factors like population growth, economic development, and rising living standards. The International Energy Agency predicts that global energy demand will continue to grow in coming decades. For example, fossil fuels like coal, oil, and natural gas currently meet most of our energy needs. However, burning fossil fuel release greenhouse gases like carbon dioxide, a major contributor to climate change. Climate change is causing rising sea level, extreme weather events, and disruptions to ecosystems. We need to transition to cleaner and more sustainable energy sources to meet our growing energy needs without harming the environment. Energy sources like solar, wind, and geothermal power offer a promising solution. For example, imagine a city during a low summer day. Everyone is cranking up their air conditioners, placing a strain on the electricity grid. Traditional power plants may struggle to meet this peak demand, leading the breakouts. Renewable energy sources like solar power can help meet this peak demand is if sufficient energy storage is available. Many remote communities rely on diesel generators for electricity, which is expensive and pollutes the air. Renewable energy source like wind power combined with battery storage can provide these communications with a cleaner and more affordable energy solution. Energy storage. Okay, so what is energy storage? Chemical, thermal, mechanical, and nuclear are the primary methods of storing large amounts of energy. Okay, chemical energy is stored in petroleum, biomass, and chemical compounds and elements. Thermal energy is stored in our mass as latent heat sensible. There are several important considerations when storing energy. Number one, the ability, recover the stored energy, the rate at which the stored energy may be converted, the rate at which store and decays. The ability to convert stored energy limits the form of energy that may be utilized in each technologies. For example, a automobile rely upon the chemical energy stored in gasoline or diesel fuel. Almost 7,500 gallons of gasoline are required over the lifetime of an automobile, which corresponds to 10 to power 9 kilojoule of gasoline. If the nuclear energy stored as mass were used instead of chemical energy, then only zero point 0.1 microgram of gasoline will be required. But the stored nuclear energy in gasoline cannot be converted to other forms in any simple manner. The rate at which energy can be converted to another form is an important consideration when various technologies. For example, we take a fry wheels may be used to store mechanical energy, but the rate at which work can be converted to kinetic energy and the subsequent discharge rate are limited by the inertia of the flywheel. And long time is required to fully charge a flywheel, and the rate of the discharge is equally long. Uh, Capacitors can charge and discharge rapidly, but the energy storage capability is significantly less than the flywheel. Finally, energy cannot be stored. Biomass contain substantial stored chemical energy. This will decompose to a less useful material with time. Similarly, flywheel will lose energy due to friction. The rate of self-discharge is an important consideration in coupling energy storage technologies with energy conversion systems. Okay, in this diagram, one second. Okay, in this diagram, Self-discharge time of energy storage system. It is show how long various energy storage system can hold a charge before losing it through self-discharge. Self-discharge is a chemical reaction that happens inside batteries and capacitors. Even when they are not being used, the x-axis of graph show the intrinsic unit sites. Okay, so this is the x-axis and show the intrinsic unit sites, and the y-axis show the self-discharge. Time in seconds to 10 percentage depth of discharge. Okay, in this diagram we show that this is a flow batteries, and this is a secondary batteries, and next this is a pumped hydro, and this is a ultra capacitors, this is fiber heats, and this is superconducting magnetic energy storage. This is biomass, biofuel, biomass. So, okay, so in this diagram, show that pumped hydro and compressed air energy storage have very low self-discharge rates. This means they can store energy for long period of time with minimum loss. Fiber heats and super capacitors also have relative low self-discharge rates. On the other hand, batteries tend to have higher self-discharge rates. This means they lose their discharge more quickly over time. The specific rate of self-discharge will vary depending on the type of battery. For example, lead acid batteries have a higher sulfur discharge rate than the lithium ion batteries. The choice of energy storage system will depend on the application. If you need to store energy for a long period of time, then a system with a low self-discharge rate, such as pumped hydro or compressed air energy storage, will be a good choice. However, if you need to store energy for a shorter period of time and then release it quickly, then a system with a higher self-discharge rate, such as a battery or fiber heat, may be more suitable. Uh, Here are some additional points to consider about the diagram. The diagram only show self-discharge time. Other factors such as cost, efficiency, and power output will also need to consider when choosing an energy storage system. The self-discharge rates shown in the diagram are for purposes only. The actual self-discharge rate of a particular energy storage system can vary depending on factors such as temperature and age. One second. Okay, so in this diagram, energy conversion. So first we study what is energy conversion. Energy conversion, also called energy transformation, okay, is the process of changing energy from one form to another form. Okay, when energy change one form to another form, then this is a energy conversion. Because we know that energy cannot destroy. Okay, energy change one form to another form. For example, a mechanical energy convert electrical, thermal. This is change energy one form to another, not destroy. Okay, so imagine you are riding, okay, we take an example for understand the energy conservation. Okay, so imagine you are riding a bike, you are using chemical energy stored in the food you eat to move your muscles. As you pedal, that chemical energy is converted into kinetic energy that makes the bike move. When you apply the brakes to slow down, the kinetic energy is converted into heat energy through friction between the brake pads and the wheels. Um, Everyday examples of energy conversion, for example, chemical energy in the gasoline is converted into heat energy during combustion, which then expands gases in the engine and creates mechanical energy to move the car. The potential energy of falling water is converted into kinetic energy as it moves through turbines, then converted into electrical energy by the generator. And next, sunlight is converted into electrical energy through the photovoltaic effect. Chemical energy stored in the battery is converted into electrical energy to power your devices. Okay, now we study this diagram. Okay, so in this diagram, first we see this is a fuel. Okay, sorry, 1 second. So this is a fuel. The fuel tank store the fuel, which is chemical energy. And next is engine. Okay, the engine burns the fuel in the process called combustion, which creates thermal energy. This thermal energy is then converted into mechanical energy by the piston. And next, this is a drivetrain. Okay, and the drivetrain transfers the mechanical energy from the engine to the wheels. The transmission changes the gear ratio between the engine and the wheels, and the differential allows the wheels to rotate at different speeds when concerned. Okay, so this is a wheels. So wheels are the car point of the contact with the ground, and are what propel the car forward. They convert the mechanical energy from the drivetrain into kinetic energy. So next, this is the electrical system. The electrical system generates and distributes electrical energy to power the car electrical components like the lights, radio, and computer. The battery stores electrical energy, and the alternator generates electricity when the engine is running. Okay, so this is a auxiliary system. This system support the engine operation. Okay, so in this radiator cools the engine by transforming thermal energy to the air. The water pumps circulates coolant through the engine and radiator. Okay, the oil pump circulates oil to lubricate the engine moving parts. Sensors monitor the engine performance and send signals to the computer. The computer controls the various aspects of the engine operation, such as the fuel mixture and timing. The diagram also shows how some of the car engine is converted into other forms of energy that are not useful for propelling the car forward. For example, some of the chemical energy in the fuel is converted into thermal energy that is lost as heat through the radiator. Some of the mechanical energy from the engine is converted into friction as the engine part move. Okay. So next is why energy storage and conversion are important. Anyone now answer this question?
Hello, Miss Amna. I just want to ask a question from previous slide. Can you come at
Yes.
previous? Can you come at previous slide? I just want to ask a question from previous slide.
Okay. Yes.
Okay, I just want to know about. First of all, we have fuel, and in fuel we have chemical energy. After combustion, this chemical energy is going to engine, and there is some kind of mechanical work. There are three
Yes.
parts: piston, crank, and flywheel. Would you
Yes.
like to tell me something about flywheel? What is meant by flywheel, and what is the main purpose of flywheel? Thank you.
Yes. 1 second. Okay. Actually, a flywheel is a mechanical device designed to efficiently store rotational energy. It is typically consists of a heavy wheel or disc that can be spin around an axis. The primary function of a flywheel is to smooth in power output and provide continuous energy when the source of power is intermittent. Okay.
Okay, it means you want to say that flywheel is converting rotational motion into like translational motion. It is converting rotational energy into translational energy. Am I right?
Yes. Yes, you are right.
Okay, okay. Thank you so much. Thank you.
Welcome. Any question? Okay, so next is why energy storage and conversion are important. Anyone can give me answer this question if now? Okay. Energy storage and conversion are critical for several reasons, impacting various aspects of modern life and addressing several global challenges. For example, solar panels generate electricity only when the sun is shining. This means there is a energy during sunny days and a shortage at night or on cloudy days. Energy storage systems such as batteries allow us to store excess air produced during the day and use it when the sun is not shining. This ensures a consistent and energy supply. Electricity grid need to maintain a constant balance between supply and demand to function correct. Energy storage system like lithium-ion batteries can quickly discharge stored energy to stabilize the grid during peak demand periods or when there are unexpected outages. Wind turbines generate electricity when the wind blows, which can be unpredictable. Energy storage system can store excess energy generated during windy periods and release it when the wind is not blowing. This allows for a higher integration of renewable energy sources into the grid, reducing fossil fuels and lowering greenhouse emissions. For example, electric vehicles rely on batteries to store energy for uses. By using electricity stored in batteries can operate without emitting greenhouse gases. Unlike traditional internal combustion engine vehicles, this help reduce air pollution and climate change. And we take one more example to understand this question. In remote where it is challenging to extend the power grid of grid solar system with the battery storage can provide source of electricity. This enables communities to access lighting, communications, and other essential services, improving their quality of life. Okay, so next, this is a types of energy storage system: mechanical energy storage, thermal energy storage, chemical energy storage, electrical energy storage. This is all types of energy storage systems. Okay, so for example, fry heats, mechanical pump hydro storage. This is a mechanical energy. Batteries use chemical energy. Capacitors use electrical energy. So in the next slides, we already discussed fiber heats. Okay, so first is battery storage. Batteries store energy through electrochemical reactions. During charging, electrons flow from an external source into a battery, causing chemical changes within the electrodes. These chemical changes store the energy. During discharging, the process reverses and electrons flow out of the battery, generating electricity. Okay, the inner working of a battery involve complex chemistry, but the basic principle is quite straightforward. Imagine a battery as a pump that pushes electrons. When you charge a battery, you are using electricity to pump electrons into the electrodes, storing them there. When you discharge the battery, these stored electrons flow out, creating an electric current. uh, we see this is a diagram. In this diagram is a inside of a battery. Okay, so in this diagram, the anode and cathode are the two electrodes in a battery cell. The anode is a typically made from a lithium ion compound. The cathode is made from a material that can easily accept lithium ions. The electrolyte is a solution that allows lithium ion to flow between the anode and cathode. The separator is a porous membrane that prevents the anode and cathode from physically touching but allows ion to flow through. The current collector collects the current from the electrodes and carries it to the external circuits. Okay, so what is the application of batteries? Electric vehicles, batteries power electric cars, providing clean and efficient transportation. We use large battery system help to integrate renewable energy sources like solar and wind into the electricity grid. storing excess energy for later use. Okay, we also use from laptops and phones to cameras and variables. Batteries are essential for powering our portable devices. Okay, so lithium-ion batteries are currently the dominant technology due to their high energy density and long lifespans. Research is ongoing to develop new battery chemistries with even better performance, such as solid state batteries that offer the faster charging times and improved safety. Battery recycling has become increasing important to ensure the sustainability of battery storage solutions. Okay, we take an example to understand the batteries. Tesla Power Pack and Tesla Power Bank and Power Wall. Tesla Power Bank and Power Wall energy storage solution are prominent example of grid scale and residential battery storage system. This system utilize a lithium-ion battery technology to store excess energy from the renewable sources or during of peak hours, providing backup power and grid stability when needed. Okay. So next is pumped hydro storage. Pumped hydro storage is one of the oldest and most widely methods of large-scale energy storage, offering grid stability and energy balancing capability. Let's into its working principle of operation, existing installation, and evaluate its pros and cons. Okay, so pump hydro storage involves using excess electricity to pump water from a lower reservoir to a higher one during periods of lower demands or higher renewable energy generation. When demand for electricity is high, water is released from the upper reservoir for flowing through turbines to generate electricity. During periods of low electricity demand or the excess generations, electricity is used to pump water uphill, storing potential energy. When electricity demand increases, water from the upper reservoir is released back down to the lower reservoir, passing through turbines which generate electricity. Okay, now we take an example for understand the working process of pumped hydro storage. Okay, for example, Dinor weak power stations walls located in the Snowdonia walls. Uh, Dino Rig Power Station is a prominent example of pumped hydro storage. It consists of an upper and lower reservoir with a capacity of around 9.1 gigawatt hour. It can generate up to 1.7 gigawatt of electricity within minutes of demand. Okay, so what is advantages and disadvantages of pumped hydro storage? So first is advantages. Pumped hydro storage system can achieve high efficiency level, typically above 70 to 80%, making them one of the most efficient methods of energy storage. This system can store large amount of energy for extended periods, providing grid stability and backup power when needed. Pumped hydro storage facilities have long lifespan, often existing 5 years within minimum degradation over time. Okay, so now next is the disadvantages. Pumped hydro storage requires specific geographical conditions such as suitable topography and access to water sources, limiting its to a certain locations. The construction of pumped hydro storage facilities can have environmental impacts, including habitats and affects our humans and environments, create pollutions. Building pumped hydro storage facilities involve significant upfront costs, including site preparations, infrastructure, and environmental assessments. Okay, so next is compressed air energy storage. Okay, so compressed air energy storage system store energy by compressing air into an undergo When electricity is needed, the compressed air is released, heated, and expanded through a turbine to generate electricity. Okay, compressed air energy storage uses a thermal energy storage unit to store the heat generated during compression and then transfers that heat back to the air during the expansion processes, making it more efficient than the conventional. Okay, so we see this is the components of compressed air energy storage. So first this is a compress. This uses electricity to compress air from the atmosphere. The compression process generate heat. Okay, so next is this is heat exchanger. Okay, this transfers the heat generated during compression to the thermal store. Or and next this is a thermal store. This store the thermal energy from the compression process the air before it enters the expander. This is a expand. This is a expand. This expands the heated air, which drives a turbine to generate electricity. And now this is exhaust air. This is the air that exits the turbine after it has been expanded to generate electricity. Okay. And one second. So now next is Freiberg energy storage. Freiberg energy storage is a kinetic energy storage system that utilizes the energy of a rotating mass to store and release energy efficiency. Okay. The fundamental of Freiberg energy storage is storing and releasing energy along with its advantages and limitations. Freiberg storage system consists of a rotating mass connected to a motor generator unit. Energy is stored by increasing the rotational speed of the Freiberg, converting electrical energy into kinetic energy. When energy is needed, the kinetic energy stored in the spinning Freiberg is converted back into the electrical energy. And next, how it stores and releases this energy. During periods of low energy demands or excess generations, electricity is used to spin up the Freiberg, increasing its rotational speeds. The kinetic energy is stored in the rotating mass of the Freiberg, ready to be rotationals. When the electricity demand increases or there is a shortage of supply, the spinning flywheels acts as a generator. The rotational energy of the flywheel is converted back into the electrical energy using the motor generator unit, providing power to the grid or specific applications. What is advantages of flywheel? Okay, flywheel energy storage system can achieve high round trip efficiency, almost 85 to 90%, making them highly efficient for short duration energy storage application. Flywheel can respond to changes in demand, making them suitable for providing frequency regulation and grid stabilization services. With proper maintenance, Freiberg system can have long lifespans, typically exist 20 years with minimum degradation over time. Okay. What is limitation of fiber heat? Fiber heat system are typically designed for short duration energy storage application due to limitations in energy density, making them less suitable for long duration storage requirements. The spinning components of fiber heat system are subject to mechanical wear over time, which can affect their and require periodic maintenance. Private heat system can still be relatively expensive to compare the some other storage technologies limited their adoptions. Okay, so we take an example. Okay, and we understand the private heat energy storage system. For example, a beacon powers private heat energy storage facility in New York, USA. Okay, Beacon Power new Renewables operates a private energy storage facility in Stephentown, New York. The facility utilizes private technology to provide the frequency regulation services to the grid, helping to maintain grid stability and reliability. It demonstrates the rapid response and high efficiency of private energy storage system in providing grid support services. Okay, in this diagram, one second. In this diagram, we say this is a energy input. Okay, this refers first the diagram show how different energy forms are converted in the power plant. Okay, in this diagram, with the help of this diagram, we understand the all components in the power plants converted energy. Okay, so first is energy input. This refers to the source of energy coming into the plant. The diagram does not specify the exact type of energy input, but it can be various forms of fuel like coal, natural gas, or biomass. And next, this is a power electronic input equipment. This equipment converts the incoming energy into electrical energy. This refers to a generator that uses the fuel energy to create the electricity. Okay, all this is electric motor. This term is not commonly used in power plant. It's possible it refers to overall conversion process from the energy source to electricity. Okay, so this is Fryer here. A Fryer is a rotating machine that store kinetic energy. Okay, we use in Fryer here actually is a main component for the designing of power plant because Fryer here store kinetic energy. Okay, this Fryer is stores excess energy generated or help regulate the flow of power output. Okay, so now we get mechanical energy. This refers to the rotation energy of the flywheel here. Last is power electronic output equipment. This equipment converts the electrical energy from the flywheel or the generator into the usable from the distribution. This likely refers to a transformer that steps up the voltage for the transmissions. Step up mean high voltages, okay? Step down mean low voltages. Into the transmission sessions, step up and step down presence. When we want to use high voltages, then we use step up, and when we want to low voltages, then we use step down. Okay, so one second. Next is thermal energy storage. Thermal energy storage captures thermal energy and store it for later use. This technology help us manage energy consumption and increase efficiency, especially with renewable energy sources. There are two types of thermal energy storage: sensible heat storage, latent heat storage, and thermochemical heat storage. Sensible heat storage, this is the most common type. It stores heat by rising the temperature of a material like water, rocks, or molten source. Think of a large insulated water tank that heats up during the day and release heat at night. Latent heat storage, this method uses material that change state during the storage process. When this material absorb heat, they change from solid to liquid and store the heat as latent energy. The reverse happens when releasing the stored energy. Paraffin wax is a common example of latent heat storage. Latent heat storage, basically when any shape convert into another form, we cannot get into initial form. Okay. And last is thermochemical heat storage. This is more complex method that uses chemical reaction to store thermal energy. Certain chemical absorb heat and undergo a reversible reaction. The stored energy is released when the reaction is reversed, while for the future, this technology is still under a development. Okay, so One second. We also now study what these advantages of thermal energy storage. Increase efficiency, had to utilize energy more efficiency by storing excess energy for later use, reducing on peak power generation. Okay. Um, Thermal energy storage can improve the reliability of renewable energy sources like solar and wind by storing energy when it's abundant and using it when it's not. Reducing emission by storing energy and reducing power demand. And thermal energy storage can help to lower on fossil fuel power plant and reduce greenhouse gas emissions. What type of challenges we face when we use thermal energy storage? Cost. Okay, system can be expensive to install and maintain. There is always some energy loss during the storage process, reducing overall efficiency. Okay, current thermal energy storage technologies have limitation on how much energy they can store and for how long. Okay, so actually this is a one second. Um, this is a diagram of sensible thermal key storage. Okay, in with the help of this diagram, we understand the conversion of energy. Okay, for example, first we take an example and understand the simple process of thermal energy storage. Imagine a house, okay, with a solar power system and an ice-based latent heat storage unit. During the day, the solar panel generate electricity, okay, that can be used to power the house and also run a refrigerator that produce ice at night. Okay, when the solar panels are not generating electricity, the ice stored during the day melts and cool the house, reducing on the grid. Okay, so this is a simple example of thermal energy storage. Now, we understand this diagram. Okay, in this diagram, first we see this is a solar collector. Okay, this captures solar energy and convert it into heat. And next, this is a packed bed storage tank. This tank stores thermal energy using a packed bed material like rocks or rocks. The heat from a solar collector is transferred to this material where it's stored for a later use. Okay, so this is a fan. This circulates air through the system. Okay, we use this fan for circulates the air from the system. uh, okay, so this is one second, this okay, this is a charging loop. When the sun is out and hitting the solar collector, thermal energy is stored in the tank. The circulation pump moves heating fluids through the collector and into the tank, heating up the packed bed material. Okay, so this is a discharging loop. When heating is needed in the house, air is drawn through the packed bed tank by the fan. The thermal energy stored in the rocks, which is then distributed throughout the house. And the last, this is a cooled air return. This is where the cooler air from the house return to the system to be reheated. Okay. So thermal energy store allows this solar heating system to operate even when the sun is not shining. The heat captured during the day can be used to warm the house at night or during the crowded periods. Okay, so we take a break. We will meet again after almost 10 minutes.
Una possibilità di Mute.
Okay. Can you hear my voice clearly?
Yes, ma'am.
Okay, so next topic is capacitor. We also know that a capacitor is a passive electronic component that can store electrical energy in an electrostatic field. It consists of two metallic plates separated by a thin insulated layer called the dielectric. What is a process of capacitor? Okay, imagine the capacitor uncharged with no potential difference between the plates. When you connect a battery to the capacitor, a current starts flowing. Electrons, negative charges, are attracted to the positive terminal of the battery and accumulate on one plate of the capacitor. The battery negative terminal repels electron from the other plate, creating a deficiency of electrons, resulting in a positive charge. As charging continues, the build-up of opposite charges on the plates creates an electric field across the dielectric. This electric field purposes further flow of current. Sorry, opposites. Okay. When the electric field becomes strong enough to a battery voltage, the charging process stops. The capacitor is now fully charged, storing electrical energy in the form of the electrical field between the plates. Okay. What is the discharging process of capacitor? Okay. Both, for example, a bulb, a electric field forces energy storage. This diagram is not clear, but no problem. Superconducting magnetic field storage, special material that conduct electricity with zero resistance when extremely cooled. Okay, a large coil of superconducting wire is kept at low temperature, very low temperature. When you pass electricity field, this magnetic field store energy. The cool part is that superconductors can hold this magnetic field without losing energy due to resistance. Okay, so in this diagram, imagine a coil like a spring. By instead of storing mechanical energy, it stores electrical energy in the form of magnetic field. Okay, the coil is submerged in a special coolant to maintain the super low temperature. In both the capacitor and the superconducting magnetic field storage, the stored electric both store the electrical field or magnetic field is used to generate electricity again. The electric field magnetic field induce a current in a circuit. This current can then be used to power devices. Okay, to what is a major difference between the capacitors and superconducting magnetic field? Okay, capacitors store energy for a short time, okay, and provide quick bursts of power. Superconducting magnetic field storage store energy for a long time and deliver to power. Where we use these energy storage of capacitors. Capacitors are useful for smoothing out in power grid or providing backup power for short outage. Okay, and the superconducting magnetic field storage can be used for similar application as capacitor, but also for large power grid or providing power for short high power devices. Okay, so next is energy conversion technologies. Okay, in the previous session, we already discussed our technologies. Okay, photovoltaic solar cells, wind turbines, fuel cells, hydroelectric power, geothermal power, and biomass conversion. Okay, so now we again understand this technology step by step in the short term. Okay, so first we see photovoltaic solar cell. Okay, PV solar cell converts sunlight directly into electricity through the photovoltaic effect. These cells are made of semiconductor material like silicon. For example, solar panels installed on rooftops or in solar farms generate electricity by absorbing sunlight. This electricity can be used to power homes, businesses, or even entire communities. So next is wind turbines. Wind turbines convert the kinetic energy of wind into the mechanical energy, which is then converted into electricity through the generator. For example, wind farms consist of multiple wind turbines placed in area with strong and consistent wind. It causes the turbine blades to rotate, spinning the generator and producing electricity. And the next, fuel cells. Fuel cells generate electricity through an electrochemical reaction between hydrogen and oxygen. They are highly efficient and produce electricity with minimum emissions. For example, we take hydrogen fuel cell are used in various applications, including transportation and stationary power generation, backup power of building, or telecommunications. Okay, next is hydroelectric power. Hydroelectric power utilizes the potential energy of water stored in reservoirs or flowing in rivers to generate electricity. Water is released from a higher elevations to a lower elevation, spinning turbines connected to the generators. Okay, now we take an example: large hydroelectric dams like the Hoover Dam in the United States or the three Georges Dam in the China generate significant amount of electricity by harnessing the power of flowing water. Second last is geothermal power. Geothermal power harnesses heat from the earth interior to generate electricity or providing heating and cooling. This heat can be through geothermal reservoirs or hot rocks deep underground. For example, geothermal power plants in the regions with high geothermal activity, such as Iceland and parts of the United States, use steam or hot water from underground to drive turbines and produce electricity. Okay, so last is biomass conversion. Biomass conversion technologies utilize organic materials such as wood, agricultural residues, waste to produce heat, electricity, or biofuels through processes like combustion, gasification, or biochemical conversion. For example, biomass power plant burn wood chips, agricultural waste, or other biomass feed stocks to generate steam, which drives turbine to produce electricity. Biogas produced from the organic waste in anaerobic can be produced to generate electricity or heat. Okay, so these are technologies of energy conversion. Okay, what is the emerging storage technologies? Okay, flow batteries, advanced supercapacitors, solid state batteries, all three emerging storage technology. Okay, so first, flow batteries. Flow batteries are a type of a rechargeable battery where energy is stored in liquid electrolyte solution. They flow through a system of pumps and storage tanks. They offer advantages of scalable energy capacity, making them suitable for large scale energy storage applications such as grid storage. Okay. Uh, now we take one example to understand the flow batteries. Okay, we take a vanadium uh, redox flow battery is a common type of flow battery. Okay, it uses vanadium ions in different oxidation states to store and release energy. These are being used in various large-scale renewable energy projects, offering long cycle life and the ability to discharge energy for extended periods. So next technology is advanced supercapacitors, also known as ultracapacitor or electrochemical capacitor. Store energy through electrostatic charges rather than chemical reactions. They provide rapid charging and discharging, making them ideal for applications requiring quick of energy. Okay, now we take an example for understand the advanced supercapacitors. Maxwell Technologies ultracapacitors are used in automotive applications such as in regenerative braking system for hybrid and electric vehicles. These supercapacitors can quickly absorb and release energy, improving the efficiency and performance of vehicles' energy management system. Last is solid state batteries. Solid state batteries replace the liquid or gel electrolyte found in conventional lithium ion batteries with a solid electrolyte. This design improves safety by reducing the risk of leaks and fires, increases energy density, and can potentially extend the battery lifespan. For example, Toyota is actively developing solid-state battery technology for its future electric vehicle. These batteries promise to deliver higher energy densities, faster charging times, and improved safety compared to traditional lithium-ion batteries. Okay, this aims to solid-state battery by the mid 2020, potentially the electric vehicles markets. Okay, what is challenges and opportunities we face in energy storage and conversion? Okay, what is challenges? Energy storage and conversion technologies face several technical challenges, including efficiency, storage capacity, integration, um, okay, enhancing the efficiency of energy conversion processes to maximize energy output and minimize losses. Developing storage system with higher energy density and longer lifespans to store renewable energy efficient. Okay, integrating renewable energy sources like solar and wind into grid and ensuring their stability. For example, one technical challenge in battery storage is improving the energy density and cycle life of lithium-ion batteries, making them more suitable for application like electric vehicles and grid-scale energy storage. Okay, so what is economic considerations? Economic factor play role in the adoption and of energy storage and conversion technology. High upfront cost for infrastructure and equipment can be barrier to adoption. Competing with conventional energy sources in terms of cost per unit of energy produced or stored, demonstrating the financial and long-term saving potential of renewable energy technologies. For example, the cost of solar photovoltaic panel have matched solar energy increase with as compared to fossil fuels in many regions, leading to adoption in residential, commercial, and utility scale applications. And what is environment impacts? Energy storage and conversion technologies have varying environmental impacts throughout their life cycle. Some technologies require rare earth metals or other material with the significant environmental and social implications or extractions. Emission from fossil fuel-based energy conversion technologies contribute to air and water pollution and climate change. Large scale of renewable energy technologies like wind and solar can have implications for land use and habitat disruptions. For example, the construction of hydroelectric dams can lead the habitat destruction, river ecosystems, and displacement of communities, highlighting the importance of carefully assessing environmental impacts. Okay, so what is the emerging trend and future prospects? Advancement in battery technology, research into next generation batteries such as solid state battery or flow batteries are most used in the future. Smart grid technologies and demand side management technology enable battery integration of renewable energy sources and improve grid. Okay, distributed energy sources like rooftop solar and community microgrid, the energy landscape promoting energy in independence. For example, the rise of vehicle to grid technology, okay, where electric vehicles can discharge energy back to the grid when not in use, hold promise for balancing grid demand and integrating renewable energy sources more effectively. Okay, now we take an example and understand the energy storage and energy conversion in the simple wording. Okay, energy storage. The swing seat hold potential energy when the person is at the top of the swing. Okay, the higher the swing goes, the more potential energy it stores. This is a similar to a battery storing electrical energy or the pumped hydro dam storing potential energy in the form of high altitude water. If now we see the energy conversion, okay, as a person swing, the potential energy at the top of the converge into the kinetic energy at the bottom of the swing. The conversion happens back and forth as they swing. This is similar to generate converting mechanical energy into electricity or a battery converting stored electrical energy to a power your phone. For example, solar panels, hydroelectric dams, your phone batteries. We already studied the convert sunlight into electrical energy, which can store in batteries for later use. They use falling water to spin turbines, which convert that mechanical energy into electricity. The water stored behind the dam acts as a form of energy storage with a higher water level representing more potential energy. It stores electrical energy and converts it to power your phone function. Okay, so my question is, how does battery storage contribute to renewable energy integration into the grid? Can anyone give me answer this question? If now,
Excuse me, miss. I would like to contribute from my side.
okay.
Basically, you are asking about how does battery storage contribute to renewable energy integration into the grid.
Yes.
Uh, okay. Basically, what does it mean by what does it mean by integration into the grid? First of all, can you explain it? Then I will. Then I would like to give the answer.
Okay. Integration means renewable energy into the grid by storing excess energy during peak production times. Okay, and releasing it when needed.
Okay, now basically batteries are contributing a lot in case of renewable energy because, for example, when we are talking about solar panels, solar is generating, converting sunlight into electrical energy. Now, batteries
Okay.
are playing a important role for the storage of that energy, and batteries are providing a kind of backup.
Hmm.
Without backup, of course, it will create a lot of problem for us. For example, at daytime, we are getting the energy, but for night, we don't have any kind of backup. Batteries are
Yes.
providing backup. Like renewable energy, solar energy. We can also talk about wind energy, like
Hmm.
the energy from the surface of sea, like sea water waves. We can also convert water waves into some kind of electrical energy. In all these cases, we need a backup, and batteries can be used as a backup.
Okay, good.
Okay.
So next my question is, how can energy storage technologies had to reduce our reliance on fossil fuels. So, Mr. Khalid, can you give me answer this question? Anyone give me answer this question? How can energy storage technologies had to reduce our reliance on fossil fuels?
Actually, I would like to give the answer of that question.
Okay.
Basically, fossil fuels are non-renewable energy resources. Fossil fuels are limited. When we are talking about fuel, any kind of like petrol, diesel, simple gas, coal, any kind of fossil fuel is non-renewable energy resources. There will be a time when when these non-renewable energy resources will be ended by the you from the use of humanity. For the use of human purpose, these fossil fuel will be ended. That is why when we are using renewable energy resources, when we are using like energy storage technologies, these technologies are helpful for the less use of fossil fuel. And if the use of fossil fuel will be less, then there will be more possibilities to use these fossil fuel for long time as compared to for short time. I think so it will be a suitable answer for this.
Yes, this answer is correct. Okay, so now my session is complete. Any question?
I have joined, ma'am. I have joined your session. I think so. Previously, I joined your session, and now in today's session, I have also joined it. And I think so. First of all, I'm very thankful to you for such nice presentation, and your way of communication, and all these slides are very helpful to understand the renewable energy technologies, and like superconductor, about discussion about batteries, and a lot of concepts are cleared in today class. And by the way, thank you so much for this.
Thank you, Mr. Zishan. So now my session is ended. Okay, Allah Hafiz.
Okay, thank you. Allah Hafiz.
Allah Hafiz.